Hey there, deep divers. We're going deep today into data storage, specifically object storage and parallel file systems.
Interesting stuff.
Yeah, we've got a ton of research and articles to dig into.
Cool.
Really try to understand how these systems work. You know, the strengths, weaknesses, when you might choose one over the other.
I'm ready.
And huge thanks to our sponsor, Stonefly.com, for making this deep dive possible.
They're great.
They're doing some very cool things in the data storage space. So if you are wrestling with, massive amounts of data,
Oh, yeah?
be sure to check them out.
I will.
So I guess to kick things off, what are object storage and parallel file systems? How would you explain those to someone who's, maybe not super familiar with the deeper side of data storage?
Sure. So object storage is kind of like a big digital warehouse
All right.
where each piece of data is an object with a unique ID and metadata. So it's like everything in this warehouse has a barcode and a description, which makes it super easy to search and retrieve specific data.
That's really interesting. So it's not just about storing the data, it's about being able to find it right.
Exactly.
Like in a warehouse, I mean, if you don't know where anything is, what's the point?
Exactly. And that's one of the biggest advantages of object storage. It's designed to scale, meaning you can easily add more storage capacity as your needs grow.
Makes sense.
That's it.
Now, what about parallel file systems? How do they fit into all of this?
Parallel file systems are more like a traditional library
Okay.
with a hierarchy of files and folders. But the data is striped across multiple storage drives.
Striped, what does that mean?
So imagine you have a really long book and you split it into chapters and you store each chapter on a different shelf.
Okay.
That's basically what striping does with data. It breaks a file into smaller chunks and distributes them across multiple disks.
So instead of reading a book from cover to cover, you're reading different chapters simultaneously.
Exactly. That's a great way to visualize it.
Interesting.
This striping technique allows for really fast read and write speeds because multiple disks can access different parts of the data at the same time.
Oh, so that's the big advantage there is speed.
Yeah.
Got it.
Yeah.
So object storage is like a massive searchable warehouse.
Yeah.
And a parallel file system is like a high-speed library.
Exactly.
I like those analogies. So I guess the next question is, why would someone choose one over the other?
So object storage really shines when you need massive scalability and cost-effective storage for large files.
Okay.
It's also perfect for cloud-based applications as it's designed to be accessed from anywhere.
Right.
Think of things like media streaming services or storing huge scientific data sets.
So if I'm a company like Netflix streaming movies to millions of users,
Right.
object storage would be a good fit.
Exactly. And consider Stonefly.
Yeah.
They offer very robust object storage solutions that are ideal for companies needing to manage large volumes of data efficiently and securely.
That makes sense.
Yep.
Now, what about parallel file systems? When are they the better choice?
So parallel file systems really excel in high-performance computing environments where speed and the ability to handle lots of simultaneous read and write operations are crucial.
Okay.
Think of applications like financial modeling, scientific simulations, or even special effects rendering for movies.
So when every millisecond counts,
Yeah.
and you need to access data lightning fast, a parallel file system is the way to go.
Absolutely. But like any technology, there are trade-offs. So while object storage is incredibly scalable and cost-effective, it can be slower for random access compared to parallel file systems.
Oh, that makes sense.
Yeah, so if you need to jump around within a data set frequently, object storage might not be ideal.
So it's not a magic bullet.
No.
It excels in certain areas, but has limitations in others.
Exactly. On the other hand, while offering blazing fast performance, parallel file systems can be more complex and expensive to set up and manage compared to object storage.
Yeah, so there's always a trade-off. High performance equals more money, basically.
Precisely. And this brings us to a fascinating aspect of distributed file systems,
Oh.
of which parallel file systems are a subset. Not all distributed file systems are created equal. The CAP theorem highlights the inherent trade-offs between consistency, availability, and partition tolerance in these systems.
Okay. The CAP theorem.
Yeah.
That sounds a bit intimidating.
Yeah, it's a mouthful.
Can you break it down for us?
Sure. In simple terms, the CAP theorem states that a distributed data store can only guarantee 2 out of these 3 properties.
Okay.
Consistency, meaning everyone sees the same data at the same time. Availability, meaning the system is always accessible even with failures. And partition tolerance, meaning the system can continue operating even if the network connection between parts of the system is disrupted.
So you can't have it all. You have to choose which 2 are most important for your specific needs.
Exactly. And this leads to different types of distributor file systems, each optimized for specific use cases. We have clustered DFS and federated DFS.
Okay.
Clustered DFS prioritizes consistency and availability. It's ideal for high-performance computing where data accuracy and system uptime are paramount.
So imagine something like real-time stock trading analysis.
Right.
You can't afford any inconsistencies in the data or for the system to go down even for a moment.
Exactly. Now, federated DFS prioritizes availability and partition tolerance.
Oh.
It's perfect for scenarios where data needs to be accessible, even with network disruptions, like remote offices accessing a central data repository.
Got it. So I'm starting to see how these different types of distributed file systems address different needs. But how does this all connect back to our initial discussion of object storage and parallel file systems?
Well, parallel file systems, especially those used in high-performance computing, often fall into the category of clustered DFS. They're designed for speed consistency and high availability within a controlled network environment.
Makes sense. Now, where does object storage fit into this DAP theorem framework?
Object storage, with its focus on scalability and eventual consistency, leans more towards the principles of availability and partition tolerance. It's built to handle vast amounts of data distributed across various locations, even if that means a slight delay in everyone seeing the same version of the data.
So it prioritizes access over absolute instant consistency.
Exactly. And understanding this helps us choose the right storage technology for a particular application. It's about matching the strengths of the technology to the specific demands of the task.
So it's not just about object storage versus parallel file systems.
Yeah.
It's about understanding the underlying principles and making informed decisions based on your specific needs.
Precisely. Let's look at some real-world examples to make this more concrete.
Okay.
Object storage is perfect for media streaming services like Netflix.
Right.
They need a system that can handle vast libraries of content scale effortlessly to accommodate millions of users and be accessed from anywhere in the world.
That makes perfect sense.
Yeah.
What about parallel file systems? Where do we see them in action?
Think climate modeling.
Okay.
These complex simulations require immense computing power and rapid access to massive data sets. Parallel file systems provide the performance needed to handle this. They're also essential in financial modeling, where split-second decisions can be worth millions.
Yeah, so when time is money, parallel file systems are often the go-to solution.
Exactly. Another great example is special effects in movies.
Really?
Those incredibly detailed scenes with thousands of characters and realistic physics rely heavily on parallel file systems to handle the enormous rendering and animation workload.
It's amazing to see how these technologies are being used in such diverse and fascinating fields. Okay, so we've covered a lot of ground here. What are the key takeaways for our listeners? What should they be thinking about when making decisions about their own data storage needs?
First, define your requirements. What kind of data do you have? How much is there and how fast is it growing?
Right.
What level of performance do you need? How important is data consistency? And of course, what's your budget? Once you have a clear picture of your needs, you can start to evaluate different storage options.
It's all about finding the right tool for the job.
Absolutely. And don't forget to consider the future. How will your data storage needs evolve? Will you need to scale up capacity or performance down the line?
So it's a strategic decision, not just a technical one.
Exactly. And don't be afraid to explore hybrid solutions. Many organizations are adopting a mix of object storage and parallel file systems to meet their diverse needs.
So you could use object storage for archiving and backups while relying on a parallel file system for high-performance computing tasks.
That's a great example. It's about leveraging the strengths of each technology to create a storage infrastructure that is both robust and efficient.
This brings up another crucial question: security. How do these systems address the ever-present threat of cyber attacks and data breaches?
That's a great point. Security is paramount, and both object storage and parallel file systems offer several features to protect your data.
Okay.
These include encryption access control and data integrity checks.
So encryption scrambles the data to make it unreadable to unauthorized individuals.
Right.
Access control restricts who can access what data, and data integrity checks ensure the data hasn't been tampered with.
Precisely. And it's worth noting that companies like Stonefly place a strong emphasis on security.
Yeah.
Offering features like data immutability and sophisticated access controls in their object storage solutions.
So when evaluating storage solutions, security should be a top priority, right up there with performance, scalability, and cost.
Yeah.
But it's not just about the technology. It's also about implementing strong security practices within your organization.
Absolutely. Regularly training employees on cybersecurity, updating software and security protocols, and conducting security audits are all essential for maintaining a strong security posture.
So it's a continuous process of vigilance and improvement.
Exactly. Now let's shift gears and talk about some of the emerging trends in data storage.
I'm all ears. What's on the horizon?
Well, one of the most significant trends is the rise of hybrid cloud
Oh,
solutions.
interesting.
Organizations are increasingly using a mix of on-premises and cloud-based storage to optimize costs, increase flexibility, and improve disaster recovery capabilities.
So you might have your primary data center on site, but use the cloud for backups, archives, or to handle sudden spikes in demand.
Exactly. And we're seeing more sophisticated hybrid cloud offerings that seamlessly integrate on-premises and cloud storage, making it easier for organizations to manage their data across multiple environments.
That makes sense. What about the impact of AI and machine learning? Those technologies are generating massive amounts of data and demanding new levels of storage performance.
That's a crucial point. AI and machine learning are pushing the boundaries of performance, scalability, and data management, leading to some really cool innovations in the storage industry.
So we're talking about faster storage media, more efficient data processing and intelligent systems that can automatically optimize data placement and retrieval.
Precisely. We're also seeing the emergence of new storage technologies like NVMe over Fabrics, specifically designed to handle the demands of AI and machine learning workloads.
NVMe over fabrics. That sounds pretty technical. Can you unpack that for us a little bit?
Sure, think of it this way. NVMe, or non-volatile memory express, is a protocol that allows for much faster data transfer between storage devices and servers.
Okay.
NVMe over Fabrics takes this a step further, extending that protocol over a network.
Okay.
This allows for high-performance access to remote storage arrays, which is critical for data-intensive AI and machine learning applications.
So it's like creating a high-speed rail line for data, allowing those AI algorithms to access and process information as quickly as possible.
That's a great analogy. And this is just one example of how the storage industry is adapting to the data-hungry nature of these workloads.
The future of data storage seems incredibly dynamic and innovative, driven by the need to manage and extract value from the ever-growing mountains of data we're generating. But with all this data, there's another critical aspect we need to touch upon: data management and governance. How are organizations tackling the increasing complexity of data security, privacy, and compliance?
That's a vital point. It's not just about storing the data, it's about managing it responsibly throughout its life cycle. Organizations need to establish clear data governance policies, implement robust security measures, and ensure compliance with regulations like GDPR and CCPA.
And this applies to both object storage and parallel file systems, right?
Absolutely. Data management and governance are fundamental, regardless of the underlying storage technology. And it's worth highlighting that Stonefly's object storage solutions incorporate features designed to support compliance and governance efforts, such as detailed audit trails and granular access controls.
So it sounds like organizations need a holistic approach to data storage, one that encompasses performance, scalability, security, and responsible data management.
Exactly. And they need to stay informed about emerging trends and advancements to make informed decisions about their data storage infrastructure.
Well, we've covered a lot of ground in this deep dive. We've explored the intricacies of object storage and parallel file systems, delved into real-world applications, discussed security and emerging trends, and emphasized the importance of responsible data management. As we wrap up, what's one key takeaway our listeners should remember?
The key takeaway is that there's no one-size-fits-all solution when it comes to data storage. The best choice depends on your specific needs, budget performance requirements, and long-term goals.
It's about understanding the strengths and weaknesses of each technology and making strategic decisions that align with your organization's overall data strategy.
Precisely. And remember, the world of data storage is constantly evolving. Stay curious, explore new technologies, and keep learning.
Great advice. A big thank you to our expert for guiding us through this fascinating deep dive, and to Stonefly for their support. Be sure to check out their website, stonefly.com, for more insights into innovative data storage solutions. Until next time, keep exploring and keep diving deep.